Welcome back. I'm going to ask you to do 3 graph algorithms and what's the difference. All right, and so I thought it'd be good to make a little video here to talk about what the heck these things are. So we're going to do Prim's minimum spanning tree. Okay, and then we're going to do Dijkstra's OSPF, and then we're going to do something called RIP. All right, these two here generate forwarding tables. Okay, and this one here generates, well, minimum spanning tree. It's minimum spanning tree. Okay, so you're going to have these graphs, whatever, and you're going to turn it into a tree. And there's different kind of trees that you might be able to get. Okay, so you start out with a graph, it turns it into a tree, and this has the least total cost for the tree. If you add, so like 1 plus 2 plus 3 is what we mean by the least total cost. It's like the weight of all the links added up. Okay, because there's some problems where turning a graph into a tree, in particular, a minimum spanning tree is what you want to do. So there's that, and we're going to do that. Then there's these other two, Dijkstra's and RIP. Now these generate forwarding tables. So these two are about forwarding tables. This one's about a minimum spanning tree. But what's a little bit confusing is that these two are similar. They're similar in the way they function. They're similar steps, let's say, but they're producing different things, right? This one's producing, Prim's is producing a minimum spanning tree. Dijkstra's is producing a forwarding table, but they're similar in their execution, all right? So let's see, let me flesh this out a little bit in here. So Dijkstra's OSPF is, it's taking a graph. You're going to start out with a graph, and you're going to generate a tree, but the tree is concerned with path lengths and the cost of those lengths. So 1, 2, 3, 4. You're concerned with 1 plus 3 is one thing, and then 2 plus 4. Like you're concerned with total length of each path. Okay, so you're concerned with this path length, whereas here whereas with the Prims you're concerned with the least total cost for the entire tree. All right, you just add up all the links for the entire tree, and that's the cost that you're interested in. But here you're interested in the least cost on the path. Okay, so Dijkstra's OSPF is concerned with path lengths. Prim's is concerned with the total tree cost, but they're similar in their execution. Okay, this thing here is going to generate a forwarding table. These two algorithms down here are going to generate forwarding tables. And what is a forwarding table? The forwarding table, so let's say you have this little tree. Let's see, 4A. So let's say A is the root, and you want to get to these destinations. Like you want to get to, well, A is not really destination, but A wants to get to B, C, D, and E, let's say. So A might get to D via, so we're going to end up storing next hop and path cost, and which we call distance. So A might be able to get to A, might be able to get to D, and via A. And let's put some costs in here. And the total path is going to be, the total distance is 1 plus 3 equals 4. And A might be able to get to E via C, and the total cost is 2 plus 4 is 6. So the 4 is going to be here really, and the 6 is going to be here. So a forwarding table for any given node just consists of this should be a B here. It should be a B. It just consists of that node's neighbors. So we're doing a forwarding table for A. So the next hops are just going to be B's and C's. So A can also get to C via C, and the total cost is 2. He can get to B via B, and the total cost is 1. All right, so the next hop information is just going to store neighbors. If we're doing a table for A, that is, it's just going to store A's neighbors and then the total path length. So this is a forwarding table. All right, so OSPF is going to do this. Now RIP is going to generate global forwarding table. Basically, what I mean by global is for each node. So whereas OSPF just generates a forwarding table for a given node, you're gonna get a forwarding table for every node. It's gonna be a two-dimensional table really, right? So OSPF is generating a forwarding table for one node, but this is for every node really, for each node, for RIP. All right, so we're going to do prims, minimum spanning tree, we're going to do Dijkstra's OSPF, and we're going to do RIP. Prims and Dijkstra's have similar function in how the algorithm works, but they generate different results. Prims generates what's called a minimum spanning tree, where you're interested in the total cost for the entire tree. OSPF generates these path lengths, and it stores the next hop and the total path length. And then RIP is a global version of that generates these forwarding tables, but for every node. Okay, so I've made separate video on how to execute prims, and another video on how to do OSPF, and another one on how to do RIP. All right, thanks.